System initialized. Chapter 1. Identifying RaccoonBot hardware. Welcome to RaccoonBot training. Starting the unboxing sequence for RaccoonBot, the educational robotic arm optimized for robotics and physical AI. The new standard for AI education. Data integration is now complete with RaccoonBot. Analyzing internal package components. RaccoonBot unit. User manual. USB-C cable. Wooden blocks. Wireless dongle. And guide stickers. Scan complete. Simply charge via USB-C to deploy RaccoonBot for any classroom session. Use the included guide stickers to visually mark the positions of the RaccoonBot and target blocks. These markers serve as an essential coordinate system for precise positioning and algorithmic design. Download XYZ coordinate maps from Robomation.net to enhance spatial perception. Utilize the X, Y, and Z axes from the map to design high-precision coding. Analyzing RaccoonBot specifications and structure. RaccoonBot is driven by a 4-axis, 4DOF joint motor system. The hardware consists of the base, number 1, upper arm, number 3, forearm, number 4, and end effector, number 6. Control operations via power, play, and delete buttons. Connect peripherals like conveyor belts for expanded tasks. System information LED guide. Status and mode LEDs output the current device state and mode via color codes. RaccoonBot supports 3 distinct coding control modes. Mode 1, Unplugged teaching mode. Manually manipulate the arm to learn principles without a PC. Mode 2, PC coding mode via wireless dongle. Access block coding, script coding, and intuitive GUI control through the Robomation Lab Block Composer solution. Mode 3, mobile app coding mode via Bluetooth. Remotely control RaccoonBot and peripherals in real time using the dedicated smartphone app. Briefing on RaccoonBot unboxing and functions is complete. Switching to standby mode.